When dealing with Whirlpool tubs and plastic plumbing, there are specific grounding considerations. The Whirlpool motor itself, being double insulated, does not typically require a separate grounding conductor. Double insulation means there are two layers of insulation protecting accessible metal parts from current-carrying components. However, the metal parts of the tub, such as the faucet, must be grounded to ensure electrical safety. This is accomplished by connecting these metal parts to a bare copper ground wire. This ground wire then needs to be run to a grounding point within the electrical system, such as the ground bar located in the electrical panel. The steps to ground these metal parts are as follows. Firstly, securely connect a bare copper ground wire to the metal parts of the tub. Secondly, run the ground wire through an appropriate opening in the wall or ceiling. Thirdly, connect the ground wire to the ground bar in the electrical panel. Fourthly, ensure all connections are tight and secure. It is important to consult with a qualified electrician to ensure proper grounding procedures are followed. Local building codes may have additional requirements for grounding in plastic plumbing systems. Remember that electrical codes, such as the National Electrical Code, or NEC, provide comprehensive guidelines for safe electrical installations. It is crucial to adhere to these codes to prevent electrical hazards and ensure the safety of occupants. When grounding metal parts, use appropriately sized grounding conductors according to NEC Table 250.122. The size of the grounding conductor depends on the size of the ungrounded conductors supplying the circuit. Ensure all connections are made within approved enclosures or junction boxes. Proper grounding ensures that any fault current will have a low impedance path back to the source, allowing overcurrent protection devices like circuit breakers to quickly trip and energize the circuit. Never rely on plastic plumbing to provide a grounding path. Plastic is a non-conductive material and cannot serve as a grounding conductor. Always use a dedicated copper ground wire for grounding purposes. When running the ground wire, avoid sharp ends or kinks that could damage the conductor. Securely fasten the ground wire to the structure to prevent it from being pulled or damaged. Use approved grounding clamps and connectors to ensure reliable connections. Inspect all grounding connections regularly to ensure they remain tight and corrosion-free. Over time, connections can loosen or corrode, compromising the effectiveness of the grounding system. If any signs of damage or corrosion are observed, repair or replace the affected components immediately. When working with electrical systems, always prioritize safety. De-energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to perform the work. Electrical work can be dangerous, and it is important to have the necessary skills and knowledge to do the job safely. Proper grounding is a critical component of electrical safety. It protects people from electric shock and helps to prevent electrical fires. By following proper grounding procedures and adhering to electrical codes, you can ensure a safe and reliable electrical system.